All right, so what we're going to do here again is we're going to convert a fraction into a decimal, but this time we're going to be using a different method, which we can call kind of the division method. And this method can work every single time. It will always work, whereas the power of 10 method will work only if you're able to turn that denominator into a power of 10. So this is a super helpful method to become familiar with because it'll work every time. There are times where you have to use it if you cannot turn your denominator into a power of 10. So, for instance, if we look here at this example of 3/4, you might have this memorized already and know the conversion, or you might not, and that's okay. But even if you do have it memorized, it's important to know how to convert it. So, what's happening here is if we ask ourselves, well, can we turn 4 into a power of 10? The answer is no, we can't. There's nothing we can multiply that 4 by to turn it into a 10, or to turn it into 100, or to turn it into 1,000. So, what we're going to, well, it's not entirely true, but we're gonna pretend like that's true. So I'm gonna show you this method here called the division method, which uh, if you can remember one thing from sixth grade math, if you can remember that a fraction bar really means divide. If it really, if you can take one thing away, remembering that a division bar like, or sorry, a fraction bar like this, it means divide. All a fraction is a division problem. That's it. So we're going to turn this 3/4 into a division problem. So we're going to say 3, we're going to take the numerator 3 and divide it by 4. So as we take that 3 and we divide it by 4, what's going to happen? We're going to say, oh, well, how many times does 4 fit into 3? Well, it doesn't, right? There's no 4s, doesn't fit. But we can say, oh, well, what about 3.0? Is 3.0 the same value as 3? Yes, it just has a little different look. So we added this decimal in, and we can pretty much ignore it now that we plop it up top in our quotient zone up here where our answer is going to go. So now we can ignore this decimal point here and say, how many times does 4 fit into 30? We know it fits 7 times, and 4 times 7 gets us 28. So as we subtract, we're going to be left with 2 left over. So since we have a remainder here, since we have some left over, we can keep going. We can keep dividing to see if we can get a more specific decimal. So we're going to drop down this 0 here, and we're going to say, oh, well, now we have a 20. So how many times does 4 fit into 20? It fits 5 exactly. 4 times 5 gets you 20. So now there's nothing left over. We can't keep going. We don't need to add, we could add a 0 here and bring it down, right? But all you're going to end up with still is 0. So we know that we have converted our 3/4 into our decimal because there's nothing left over here. This is as specific as we can be. So our decimal is 0.75 or 75 hundredths. You can put a 0 here or not. Either way is legit because both are implying that there are 0 in the ones or in the units place value spot.